The world of aviation in the mid-20th century was largely an American show. Companies like Boeing, McDonnell Douglas and Lockheed dominated the skies. They built the big jets, they sold them to airlines across the globe. European aircraft manufacturers were smaller, they often focused on national projects. This made it hard to compete on a global scale. The dream of a united European aerospace power began to take shape. Leaders saw the need for collaboration. They knew that only by working together could European nations challenge American dominance. This was not just about building planes, it was about reclaiming technological leadership. The idea was ambitious. It required governments to put aside old rivalries. It meant pooling resources, knowledge and industrial might. Early discussions were complex. There were many political and economic hurdles to overcome. Different countries had different priorities, yet the vision of a strong, competitive European aircraft builder persisted. The potential benefits were huge. A successful consortium could create jobs. It could drive innovation. It could give Europe a powerful voice in the global aviation market. The spirit of cooperation slowly started to win. The stage was being set for something truly groundbreaking in industrial history. The significance of what would become Airbus transcended mere business. It was a symbol of European unity. It represented a belief in collective strength. In a continent historically marked by division, this was a powerful statement. The project aimed to prove that European countries could achieve more together than apart. This shared purpose became a driving force. It helped navigate the inevitable disagreements and setbacks. The goal was clear: to build world-class aircraft. These aircraft would be technologically advanced, they would be efficient, and they would carry the flag of European ingenuity to every corner of the world. The journey would be long and difficult. Many doubted that such a complex international venture could succeed. The established American giants were formidable competitors. They had vast resources and deep market penetration. But the pioneers of Airbus were driven by a powerful conviction. They believed in their engineering skills. They believed in their vision for a new generation of aircraft. The dream of a European aerospace champion was slowly, painstakingly taking its first steps toward reality. The world was about to witness the rise of a new force in the skies. This force would change aviation forever. Airbus Industrie was formally established as a Groupement d'intérêt économique on December 18, 1970. This unique legal structure allowed companies from different nations to collaborate. The initial partners were France's Aerospatiale and Germany's Deutsche Airbus. Spain's CASA joined a few months later, in 1971. The United Kingdom, initially hesitant, would later join through Hawker Siddeley, which designed and manufactured the wings. This multinational foundation was both a strength and a challenge. It brought diverse expertise, but it also required careful coordination of different engineering philosophies and manufacturing processes. The early days were marked by intense effort to make this complex partnership work smoothly. The financial risks were immense. Developing a new airliner costs billions. There was no guarantee of success. The market was skeptical of a new European entrant. Airlines were comfortable with established American products. Convincing them to buy an unproven aircraft from a new consortium was a monumental task. Governments provided crucial seed funding. Yet, they also expected results. The pressure to deliver a competitive product on time and within budget was enormous. Early Airbus leaders like Henry Ziegler and Roger Bettet displayed remarkable vision and tenacity. They navigated political complexities and technical hurdles with great skill. One of the biggest initial challenges was integrating the disparate national industries. Each country had its own aerospace champions, its own ways of working, building aircraft sections in different countries and then assembling them in Toulouse, France, was a logistical feat. This work-sharing model was essential for political buy-in from partner nations. It ensured that each country benefited economically. However, it also added layers of complexity to design, manufacturing, and supply chain management. Overcoming these internal divisions and fostering a unified Airbus spirit was key to the consortium's survival and eventual success. Language barriers and cultural differences also had to be managed carefully. Securing the first orders for their launch aircraft, the A300, was a critical early battle. Many airlines were wary. They questioned whether this new European consortium could provide reliable aircraft and, importantly, long-term support. Lufthansa, Germany's flag carrier, played a vital role by placing an early order. This provided a much-needed vote of confidence. Air France naturally also came on board, but breaking into markets dominated by American manufacturers required patience and persistence. The Airbus sales teams worked tirelessly. They emphasized the A300's innovative features and economic benefits. Each small victory in these early years was hard-won. The Airbus A300 was the consortium's first aircraft. It was a truly pioneering concept for its time. The idea was a wide-body aircraft with just two engines. Most wide-bodies then, like the Boeing 747 or Douglas DC-10, had 3 or 4 engines. A twin-jet wide-body was designed for short to medium-haul routes. This was a segment of the market that Airbus believed was underserved. The A300 aimed to offer the passenger comfort of a larger jet, but with better fuel efficiency. This was a bold gamble. Some in the industry doubted that a twin-engine aircraft could be reliable enough for wide-body operations. Airbus was determined to prove them wrong. The design philosophy behind the A300 focused on efficiency and advanced technology. It featured a newly designed wing with a supercritical airfoil. This wing was highly efficient, providing excellent lift and reducing drag. This contributed significantly to the A300's fuel economy. The aircraft also made extensive use of composite materials for the first time in a commercial airliner, particularly in secondary structures. This helped to reduce weight, further improving performance. The fuselage cross-section was optimized to carry standard LD3 cargo containers side by side, a feature that appealed to airlines looking for freight revenue. Passenger comfort was also a key consideration in the spacious cabin layout. Despite its innovative design, sales of the A300 were initially very slow. Airlines were cautious. The oil crisis of 1973, however, began to shift perspectives. Suddenly, fuel efficiency became a top priority. The A300, with its 2 fuel-efficient engines, started to look more attractive. Airbus offered creative sales tactics, including leasing aircraft to potential customers to let them experience the benefits firsthand. The real breakthrough for the A300 in the crucial US market came in 1978. Frank Borman, the former astronaut and then CEO of Eastern Airlines, placed an order for 23 A300 AS. This was a massive endorsement. It showed that a major American airline believed in the Airbus product. The Eastern Airlines order was a turning point. It opened doors to other airlines around the world. The A300 gradually gained acceptance and proved its reliability and economic advantages. It established Airbus as a serious player in the commercial aircraft market. The A300 family was later expanded with the A300-600, featuring a 2-crew cockpit and improved performance, and the shorter A310. The A300 was not just an aircraft, it was the foundation upon which Airbus built its future success. It demonstrated that European collaboration could produce a world-beating product. It proved that innovation could overcome established market dominance. Airbus quickly established a reputation for embracing and pioneering new technologies. This commitment to innovation became a core part of its identity. It was a key differentiator in a highly competitive industry. The company understood that technological leadership was essential to challenge the status quo. From the very beginning, research and development were given high priority. Airbus engineers were encouraged to think boldly and explore new frontiers in aircraft design and manufacturing. This forward-thinking approach led to several breakthroughs that significantly impacted the entire aviation industry. The aim was always to make aircraft safer, more efficient, and more economical to operate. One of the most significant innovations introduced by Airbus was digital fly-by-wire flight control systems. This technology replaced conventional manual flight controls with an electronic interface. Pilot inputs are transmitted to the flight control surfaces by electrical signals. The A320, launched in the 1980s, was the first commercial airliner to feature a full digital fly-by-wire system. This was a revolutionary step. Fly-by-wire systems offered numerous benefits. They included enhanced flight safety through built-in protections, reduced pilot workload, and lighter aircraft weight due to the elimination of heavy mechanical linkages. It also allowed for more optimized aerodynamic designs. The introduction of fly-by-wire also led to another Airbus innovation, the common cockpit philosophy. Because flight characteristics were managed by software, Airbus could make different aircraft models feel and behave very similarly from a pilot's perspective. This meant that pilots trained on one Airbus fly-by-wire aircraft type could transition to another with significantly reduced training time and cost. This was a major selling point for airlines operating diverse Airbus fleets. It improved operational efficiency and flexibility for airlines. The common cockpit, along with side-stick controllers instead of traditional yokes, became a hallmark of Airbus aircraft. Beyond flight controls, Airbus also pushed the boundaries in materials science. The A300 had already incorporated composites, but later models saw a dramatic increase in their use. Aircraft like the A350XWB feature over 50% composite materials by weight, primarily carbon fiber reinforced plastics. These materials are lighter and stronger than traditional aluminum alloys. They also offer better resistance to fatigue and corrosion. This extensive use of composites contributes to lower fuel burn, reduced maintenance costs, and improved environmental performance. Airbus continuously invested in new manufacturing techniques to work effectively with these advanced materials, keeping it at the forefront of aerospace manufacturing. Section 5. The A320 family revolutionizing the single-aisle sector. By the early 1980s, Airbus had established itself with the A300 and A310 wide-body aircraft. However, the largest segment of the commercial aircraft market was the single-aisle, narrow-body category. This market was overwhelmingly dominated by the Boeing 737 and the McDonnell Douglas DC-9 MD-80 series. Airbus recognized that to become a truly global player, it needed to challenge this dominance. Planning began for a new aircraft, initially codenamed SA, or Single Aisle. This project would eventually become the Airbus A320. The goal was ambitious: to create a technologically superior aircraft that would offer airlines significant advantages in efficiency and performance. The Airbus A320, which first flew in 1987, was a game-changer. It was the world's first commercial aircraft to feature a full digital, fly-by-wire flight control system. This was a radical departure from the conventional controls found on its competitors. It also introduced side-stick controllers for the pilots, replacing the traditional control yokes. This created a more ergonomic and spacious cockpit environment. The A320 also boasted a wider cabin than its main competitor, offering greater passenger comfort and flexibility in seating arrangements. Its advanced aerodynamics and fuel-efficient engines made it highly economical to operate. These innovations set a new standard for single-aisle aircraft. The market response to the A320 was phenomenal. Airlines quickly recognized the benefits of its advanced technology and operating economics. Orders poured in from around the world. The A320 became the fastest-selling airliner in history at the time. It posed a serious challenge to Boeing's long-held supremacy in the narrow-body market. The success of the A320 was a testament to Airbus's courage in embracing cutting-edge technology. It validated the company's innovative approach and firmly established Airbus as a leading force in commercial aviation. The intense competition spurred by the A320 led to further innovations from both Airbus and Boeing, benefiting the entire industry. Airbus capitalized on the A320's success by developing a family of aircraft based on the same design. This included the shorter A319, the even shorter A318, and the stretched A321. This family concept offered airlines great flexibility. They could choose aircraft of different sizes to match various route demands while benefiting from commonality in pilot training, maintenance, and spare parts. This commonality significantly reduced operating costs. The A320 family continued to evolve with enhancements like shark-clip wingtips and the new engine option, or NEO program, which offered even greater fuel efficiency. The A320 family remains a cornerstone of Airbus's product line and a global bestseller. Section 6. Reaching for the stars, the ambitious A380 Super Jumbo. In the late 1990s and early 2000s, Airbus embarked on its most ambitious project yet, the A380. The vision was to build the world's largest passenger airliner. It would be a full double-deck aircraft designed to carry over 500 passengers in a typical three-class configuration and up to 853 in an all-economy layout. Airbus saw a future market where air traffic growth, particularly on long-haul routes between major hubs, would necessitate such a large aircraft. The A380 was designed to alleviate airport congestion by carrying more passengers per flight. It was a monumental undertaking, pushing the boundaries of aerospace engineering and manufacturing. The engineering challenges involved in developing the A380 were immense. Its sheer size and weight required innovative solutions for everything from structural design to landing gear. Manufacturing the A380 was a complex logistical operation, with large sections of the aircraft built at Airbus facilities across Europe, wings in the UK, fuselage sections in France and Germany, and tailplanes in Spain. These massive components then had to be transported by road, barge, and a specially designed roll-on/roll-off ship to the final assembly line in Toulouse, France. This intricate production system was a marvel of industrial coordination, but it also presented significant risks of delays. The key selling point of the A380 was the unparalleled passenger experience it offered. The vast cabin space allowed airlines to install luxurious amenities, such as onboard lounges, bars, showers, and private suites. Even in economy class, passengers benefited from wider seats and more personal space compared to other aircraft. The A380 was also designed to be exceptionally quiet, both internally for passengers and externally, meeting stringent airport noise regulations. Airlines that operated the A380 often highlighted these comfort aspects in their marketing. The aircraft quickly became a favorite among long-haul travelers who appreciated its smooth ride and spacious environment. Despite its technological marvels and passenger appeal, the A380 faced commercial headwinds. The market for very large aircraft did not develop as Airbus had forecast. Airlines increasingly favored smaller, more fuel-efficient twin-engine jets like the Boeing 787 and Airbus's own A350. These aircraft offered greater route flexibility. Production of the A380 was plagued by early wiring installation issues, leading to costly delays. While prestigious airlines like Emirates became major operators, overall orders remained below expectations. In 2019, Airbus announced that A380 production would end in 2021. Though its production life was shorter than hoped, the A380 remains an icon of aviation engineering, a testament to Airbus's bold vision. Section 7. Navigating stormy skies, competition and enduring challenges. The journey of Airbus has been one of constant competition, primarily with its American rival, Boeing. This rivalry is one of the most intense and closely watched in global business. For decades, the two giants have battled for market share, airline orders, and technological supremacy. This competition has been fought in sales campaigns, at air shows, and even in international trade disputes. Both companies have accused each other of receiving unfair government subsidies, leading to lengthy cases at the World Trade Organization. This fierce duopoly has in many ways pushed both manufacturers to innovate faster and offer better products, ultimately benefiting airlines and passengers. Airbus has also had to navigate numerous economic downturns that have impacted the aviation industry. Events such as the oil crises of the 1970s, the Gulf War in the early 1990s, the aftermath of the September 11th terrorist attacks in 2001, the global financial crisis of 2008, and more recently, the COVID-19 pandemic, all led to sharp declines in air travel and aircraft orders. During these challenging periods, Airbus had to make difficult decisions. This included adjusting production rates, managing its workforce, and providing support to its airline customers. The cyclical nature of the aerospace industry requires resilience and careful long-term planning. Production challenges and program delays have also been part of the Airbus story. The A380 program, as mentioned, suffered significant setbacks due to complexities with wiring harnesses. This highlighted the difficulties of coordinating highly intricate manufacturing processes across multiple countries. The development of the A350 XWB, while ultimately very successful, also experienced its share of delays as Airbus worked to integrate advanced technologies and materials. Managing vast global supply chains and ensuring consistent quality across all production sites remains an ongoing operational challenge. These experiences, however, have led to valuable lessons and improvements in project management and industrial processes. Furthermore, Airbus has had to constantly adapt to evolving environmental regulations and the growing demand for more sustainable aviation. The pressure to reduce fuel burn, emissions, and noise pollution has driven significant research and development efforts. This includes designing more aerodynamic aircraft, developing lighter structures, and investing in more efficient engine technologies. The push for sustainability is not just an external pressure, it has become a core part of Airbus's strategy for the future. Meeting these environmental goals while maintaining competitiveness is a key challenge that will shape the company's direction for decades to come. This requires long-term vision and substantial investment in green technologies. Section 8: Milestones and Triumphs, Building a Legacy of Success. Despite the challenges, Airbus's journey is overwhelmingly a story of remarkable achievement. From its uncertain beginnings as a government-backed consortium, it has grown into a global aerospace leader. A major milestone was reached in 2003 when Airbus delivered more aircraft than Boeing for the first time, a position it has held or closely contested in many subsequent years. This marked a significant shift in the balance of power within the commercial aviation industry. It was a clear signal that the European collaboration had not only succeeded, but had become a dominant force. This achievement was the culmination of decades of hard work, innovation, and strategic risk-taking. Airbus has significantly expanded its global footprint over the years. While its main design and assembly centers remain in Europe, the company has established final assembly lines in other key markets. In 2008, an A320 final assembly line was opened in Tianjin, China, recognizing the growing importance of the Asian market. This was followed by another A320 family assembly line in Mobile, Alabama, USA, in 2015, taking the competition directly to Boeing's home turf. These international facilities help Airbus to be closer to its customers, manage currency risks, and tap into local talent pools. They also represent a strategic move to build global partnerships. The success of Airbus extends beyond commercial aircraft. The company has diversified its portfolio through the creation of Airbus Defence and Space and Airbus Helicopters. Airbus Defence and Space is a major player in military aircraft, satellites and space exploration systems. It produces aircraft like the A400M military transporter and the Eurofighter Typhoon as part of a consortium. Airbus Helicopters is one of the world's largest helicopter manufacturers, serving both civil and military markets. This diversification provides greater stability to the overall Airbus group, helping to balance the cyclical nature of the commercial aviation business. Each division benefits from shared research and technology. Celebrating major delivery milestones has become a regular occurrence, highlighting the scale of Airbus's operations. The delivery of the 1,000th A320 family aircraft, the 5,000th and then the 10,000th Airbus aircraft overall, were all significant moments. These events underscore the company's manufacturing prowess and its deep impact on global air travel. Airbus has not only created tens of thousands of high-skilled jobs directly, but has also supported a vast network of suppliers across Europe and worldwide. Its contribution to the European economy and its role in fostering technological innovation are undeniable. The legacy of Airbus is one of ambition, collaboration, and enduring success. Section 9. The future is Airbus charting the next course in aviation. As Airbus looks to the future, its focus is increasingly on sustainability. The aviation industry faces immense pressure to reduce its environmental impact. Airbus is at the forefront of research into new technologies to achieve this goal. A key initiative is the Zero concept, which aims to develop the world's first zero-emission commercial aircraft powered by hydrogen. Airbus is exploring various hydrogen propulsion technologies, including hydrogen combustion in modified gas turbines and hydrogen fuel cells. The company has set an ambitious target to bring such an aircraft to market by 2035. This represents a monumental technological challenge, but also a significant opportunity to revolutionize air travel. The development of next-generation aircraft will also involve further advancements in digital design, manufacturing, and operations. Airbus is heavily investing in digitalization across its entire value chain. This includes using advanced data analytics, artificial intelligence, and the Internet of Things to optimize aircraft performance, improve predictive maintenance, and enhance the passenger experience. Future aircraft will be more connected, more intelligent, and more efficient than ever before. The Airbus Skywise data platform is an example of how the company is leveraging big data to provide insights to airlines, helping them improve their operational efficiency and reliability. The competitive landscape will continue to evolve. While the rivalry with Boeing remains central, new potential competitors may emerge from countries like China. Airbus must continue to innovate and adapt to maintain its leading position. This includes ongoing improvements to its existing product lines, such as the A320neo and A350 families, which offer significant fuel savings. It also means anticipating future market needs and developing aircraft that meet those demands. The ability to be agile and responsive will be crucial in a rapidly changing global environment. The company must also manage its complex global supply chain effectively. Airbus's vision for the future of air travel is one that is safer, more efficient, and significantly more sustainable. The pioneering spirit that led to its founding continues to drive the company forward. From the first A300 to the ambitious Zero concepts, Airbus has consistently pushed the boundaries of what is possible in aerospace. The journey ahead will undoubtedly have its challenges. However, with its strong legacy of innovation, its skilled workforce, and its commitment to shaping the future, Airbus is well positioned to continue its leading role in the global aviation industry for many years to come. The sky is truly the limit for this European success story,